Aristotle's influence in learned circles was such that even centuries after his death he was known simply as the philosopher. Aristotle saw the cosmos divided into two realms, the terrestrial and the celestial. The terrestrial realm included the Earth, the Moon, and the space between them, called the sublunar region. The terrestrial realm was marked by change and imperfection. The celestial realm was the region above the Moon. Here there was complete order and perfection. Aristotle's model showed the planets in the celestial realm moving around the Earth in an orderly manner, in perfect circles and with uniform motion, neither speeding up nor slowing down. As a philosophy, this model worked very well. However, it did not explain why planets appeared to slow down and speed up in their movements. Nevertheless, Aristotle's universe was the accepted model until the 17th century. Aristotle's model of the universe had trouble explaining some planetary phenomena. The most striking of these was retrograde motion. In retrograde motion, each planet seems to slow down at times, then move in reverse or retrograde before resuming its course. Planets also grow brighter or dimmer as they move through the sky. Aristotle's model could account for neither phenomena very well. The most important solution to this problem was proposed by Claudius Ptolemy in the 3rd century A.D. He argued that planets move on two sets of circles, a deferent and an epicycle. This explained retrograde motion while keeping the planets in their circular orbits around the Earth. Where this did not fit, Ptolemy proposed an eccentric. An eccentric orbit had a center different from the Earth and accounted well for changes in a planet's brightness. Ptolemy's last device was the equant. In an equant, a planet speeded up and slowed down, but when seen from an off-center point, actually appeared to be moving with uniform speed. From Earth, however, the planet's motion was quite irregular. The Ptolemaic system held ground for centuries, until too many discrepancies cried for new solutions. By the 16th century, Ptolemy's geocentric system had accrued many problems. The position of the sun and planets was not where Ptolemy had predicted, and there was dispute in the order of the planets. Nicholas Copernicus resolved these problems by placing the sun in the center of the system. This was a revolutionary concept, and it raised some new problems, but it was elegant and could account for retrograde motion. For Mars, Jupiter, and Saturn, retrograde motion occurred when the Earth, moving more quickly in its orbit, overtook one of the outer planets. Likewise, the retrograde motion of Mercury and Venus occurred when these planets overtook and passed the Earth. The Copernican system also firmly placed Mercury closest to the Sun and Venus between Mercury and Earth. Unlike Ptolemaic models, this heliocentric order could not be amended without destroying the entire system. In the early 17th century, Johannes Kepler challenged two features of the Copernican system. In the Copernican system, the planets moved uniformly in circles, much like the Ptolemaic model. However, through observations of Mars, Kepler came to several conclusions. Published in 1609, Kepler's first law states that planets move in elliptical orbits with the Sun at one focus. Kepler's second law states that a planet's orbital speed is not uniform. A planet moves slower when it is farther from the Sun, and faster closest to the Sun. The relationship between time and area, however, remains constant. Kepler's laws destroyed the last vestiges of Aristotle's model of the universe.